Greetings, this is Mr. Caslin. Today let's do a little SAT question of the day. Get you ready for your math SAT. Alright, if you want to, go ahead and pause the video, read through the question and see how you would answer it. This is a word problem. I do know that some of you get word problem paralysis. You see a word problem and you automatically go, oh, I can't do this. And you haven't even read through the problem yet, so give it a chance. It's just interpreting these English words and understanding what they're asking. Right, so what it's saying is a manager estimates that if a company charges P dollars for their new product, then the revenue of the product will basically be this function. Okay, so you're dealing with a function. Remember, functions have input and output. Right, their input is price. They're saying the price is between $0 and $200. And they're trying to see what should they set the price at to maximize their revenue. Right, what input for P will give them the maximum revenue for the week. Okay, well, automatically, why wouldn't you just say the largest price would give you the maximum revenue? Well, it's because this function is negative 10p squared. It's a quadratic. Algebra 2, you did a lot of quadratics. You knew that negative x squares were parabolas that were upside down. Okay, so what does that mean? It means, well, as they start increasing their price, their revenue goes up. Their revenue goes up, but isn't there going to be some point where, okay, they're charging too much for this product. Less people are starting to buy it. They're increasing the product more, and less people are starting to buy it. So there's going to be this optimal price, okay, that's going to give you optimal revenue. So you increase the price until it starts turning people off, basically. Okay, so let's find this price. Now, we could do a lot of mathematical calculations to do this, but hey, we put your graphing calculator to work for this. Okay, let's just graph this and see what happens. Alright, so I've placed the function in here, 2000x minus 10x squared. Remember, the calculator, when it talks about inputs, it uses the variable x. In the word problem, they use the variable p. It's just a symbol, doesn't matter what symbol you use. Okay, now here's the tricky part. When you go to graph this, first of all, there's nothing there. Okay, well, it's because this is way off the graph. If you think about this, this 2000p term is going to make this a very large portion of your graph, and we can't see it right now. We could say zoom. There is a function on your calculator, zoom fit, okay, to try to fit it into the window. And it's making it look linear. It makes it look like a line. Well, that's kind of deceiving. What's really happening is this parabola is really, really flat. Okay, no. So what I want to convince you is don't worry so much about the graph. What we want to look at is the input-output table. Remember algebra, you created input-output tables. You figure out what the value for x is. So if x is 0, plug 0 into x, or in this case p, and figure out what your output is. In this case, input of 0 would give you an output of 0. Okay, the calculator can do that for you. Okay, go to second table. You've got it, here's your 0, 0. If x is 1, then y is 1,990. So what that's saying is if they're charging $1 for their product, then their revenue for the week would be $1,990. Now look at this revenue starting to grow. If they increase it to $2, all right. So I want to look at 10, 20, 50, 100, and 200 and see which one is the largest. Okay. One of the things you can do on this calculator is in this table screen, if you hit the plus sign, it'll allow you to do delta table. That just means instead of going up by 1, let's go up by 10. Okay, now notice, oh, but I was starting at 3. Okay. Okay, when you do that, just have your cursor on 0. That'll work out better. In fact, let's go back to the table. Let's do a delta 1, go back to where it's 1. Oh, flub, god damn it.